we still have enough CFCs and other ozone depleting substances in the atmosphere to cause ozone depletion when the other conditions are appropriate. So currently it's a matter of the dynamics and of the temperature profile in the stratosphere, whether we get ozone depletion or not. And that will truly not change very dramatically for the next 20 years. Only then we can expect that the levels of CFCs have dropped so much if the situation or the development continues as now, that even under favorable depletion conditions we won't get an ozone hole. But that remains to be seen, and if we don't have any instruments left to check this, we'll have a big problem to verify that it's working. That is maybe one of the most important developments in climate modeling, that especially here at high latitudes in the Arctic and in the Antarctic, it's important not to limit the climate models to the lowermost part of the atmosphere, which was done in the early stages of climate and atmospheric Earth system modeling. Only when one included the stratosphere and the ozone layer in these models, they started to reproduce very important patterns, such as the North Atlantic Oscillation, in a satisfactory way. So it's really it makes the models much more reliable when you include as much of the atmosphere as possible and as much as feasible from a technical point of view. So in the Arctic, it's very important that we include the stratosphere and the ozone layer in the climate modeling. There is obviously a belief that now the problem is solved because one has taken political action. But any model which is serious about ozone layer processes, about recovery of the ozone layer, says we cannot expect the ozone hole to vanish before around 2040 or 2050. And we have experienced many surprises during the last 30, 50, 40 years. So I would not be surprised to get more surprises during the decades to come, until we can state that the ozone layer truly has recovered. Especially because the whole atmospheric system, the climate system, is changing dramatically. And as the ozone layer and the stratosphere are an integral part of the global atmosphere, there will be effects of these other changes on the stratosphere and on the ozone layer. There are predictions about how these couplings and how these feedbacks work, but they have been changed a lot since the mid-90s, and I would also expect that they are going to change in the future. So we don't understand this system fully, and we do not even know how the system is going to change besides the ozone layer and the stratospheric dynamics.